Welcome back to the Math Magic Lab. Today, we are taking the fear out of calculus. Many students are scared of the chain rule, but in this lab, we make the difficult look easy. We've got 3 levels of examples to show you that you can master this. No more confusion, no more stress. Let's break it down together. The experiment begins now. Don't let the name scare you. The chain rule is just a simple way to break down a big, complicated function into 2 smaller, easy pieces. Think of these 2 circles on your screen as the outside and the inside. To find the derivative, we just connect the dots. First, we identify our layers. Let's look at our first problem. Now, let's look at our first challenge. We have f(x) equals 3x squared plus 5, all raised to the power of 4. To use the chain rule, we just need to identify which part is inside the parenthesis and which part is outside. Don't blink, because once you see the layers, the math becomes easy. Here is the secret. We give our layers names to make them manageable. The inside is our u, which is 3x squared plus 5. That leaves the outside as just y equals u to the power of 4. Think of it as breaking a heavy chain into 2 small links. Once you have these 2 pieces, the rest of the problem is just simple differentiation. Now, we differentiate each part. For the outside, we bring the power of 4 to the front and drop the exponent by 1, giving us 4u cubed. For the inside, the derivative of 3x squared plus 5 is simply 6x. We now have our 2 magic numbers. One for the outside, one for the inside. Let's put them together. Now for the magic moment. The chain rule tells us to take those 2 pieces we just found and multiply them together. We take our outside derivative, 4u cubed, and multiply it by our inside derivative, 6x. It's like clicking 2 pieces of a puzzle into place. And just like that, the mystery is gone. By following our 3 steps, identifying the layers, differentiating each part, and applying the rule, we found our final answer, 24x times 3x squared plus 5, all cubed. You just mastered the chain rule. If you want to keep making math look this easy, join us in the lab. Level 2. The trigonometry twist. Don't let the sine function intimidate you. Whether it's a power or a trig function, the logic remains exactly the same. We identify the layers, we derive, and we combine. Example 2. Let's turn up the heat. We are looking at composite functions involving trigonometry. The rule stays the same. We differentiate the outside and the inside separately. In this case, we are tackling the sine function. Don't worry, it follows the exact same logic as our first experiment. Let's identify our layers. Now we identify our layers for the trigonometric function. Our outside layer is the sine function, and our inside layer is 5x cubed. By setting u equal to 5x cubed, we can rewrite the whole problem as y equals sine of u. This simple switch makes the calculus much easier to handle. Step 1. We differentiate the outside layer. The derivative of sine with respect to u is simply cosine of u. We've successfully opened the outer box. Now, we just need the derivative of what's inside. Step 2. Now we differentiate the inside. We take our u value, 5x cubed, and apply the power rule. 3 times 5 gives us 15, and we reduce the exponent by 1. Our inside derivative is 15x squared. We have both pieces ready for the final step. To finish, we simply rearrange the terms for a cleaner look. The 15x squared moves to the front, followed by the cosine of 5x cubed. This gives us our final derivative. Example 2 is complete, and the math is perfectly organized. To wrap up example 2, remember the 3-step process. First, identify your outside and inside functions. Second, differentiate each one separately. Finally, apply the chain rule to bring them together. Following this method makes even complex trigonometric derivatives simple and consistent. Example 3, the radical challenge. We are facing a function with a square root. Many students get stuck here, but the secret is simple. We just rewrite the radical as a fractional exponent. Once we do that, the chain rule works exactly the same way as before. Let's break down the final boss of this session. Before we tackle our final challenge, remember what a derivative actually is. It's simply a measure of how a function changes. Whether we are dealing with powers, trigonometry, or square roots, we are just tracking that change step by step. Now, let's apply everything we've learned to our most complex shape yet. Step 1 for any radical function. Rewrite it. We turn that square root into a fractional exponent of 1/2. Now, it looks just like our first example, and we can apply the power rule logic to our outside layer. This is the key to unlocking the problem. Now we apply the chain rule. We define our outside function g, u, as u to the 1/2 power, and our inside u as x squared plus 1. Differentiating the outside gives us 1/2 times u to the negative 1/2, while the inside derivative is simply 2x. Multiplying them together, we get our raw derivative. It looks complex, but we are just one simplification away from the finish line. Step 3 is all about the cleanup. We combine our terms into a single fraction, placing the 2x in the numerator. At first glance, this looks finished, but notice the coefficients. We have a 2 on top and a 2 on the bottom, and in the MathMagic lab, we never leave a fraction unsimplified. By cancelling out the common factor of 2, we arrive at our final, elegant result x over the square root of x squared plus 1. You've just conquered the radical challenge using the chain rule. And that's the chain rule mastered. We've tackled powers, trigonometry, and radicals, all using the same simple outside-inside logic. If you followed along, you're now ahead of the curve. Keep practicing these steps, and calculus will start feeling like second nature. Thanks for joining me in the lab. See you in the next lesson.